This video shows the combined lessons learned of crew interior access to the Apollo, Shuttle, and Constellation spacecraft at the pad. Using mock-ups and design visualization tools, it is possible to identify costly issues with the pad interface early in the development cycle.
Green screen video was generated of tests performed by the flight and emergency crew in a specially built crew access arm mock-up. It was then combined with 3D models to visualize the scenarios at the pad.
Crew access to manned spacecraft is normally established at the pad after rollout. An environmental chamber, commonly called a white room, is needed to protect the vehicle cleanliness. Here's the shuttle white room interface.
The orbiter crew access arm interface relies on the geometry of the integrated stack and presses an inflatable dock seal against the side of the vehicle. The orbiter skin is relatively durable and capable of absorbing surface friction associated with the inflatable dock seal.
Here's how Apollo managed the interface.
Apollo's interface used a remotely operated clamp that removed any gaps for the crew to step over during an escape.
Crew access arm connection. In the case of this vehicle, the seal is mechanically attached to the spacecraft.
No threaded fasteners should be required during launch countdown or crew egress.
Any steps required to build this interface must also account for fall hazards, weather, and relative movement of the vehicle and white room. Often this task has to be performed during a scrub turnaround where the launch has been canceled due to inclement weather and the crew cannot leave until access is established. Access to service panels needs to be accounted for in the interface design.
The crew access arm design provides environmental protection to the interior of the spacecraft if needed. Several types of requirements have driven previous designs, including spacecraft cleanliness levels, humidity that can cause condensation on critical components, precipitation, which is of particular concern at the spacecraft's CAA interface seal during high winds and inclement weather, oxygen deficiency in confined spaces that may result from spacecraft purges. The crew access arm should remotely attach to the vehicle structure. During Apollo, a strong interface was achieved by attaching a compliant portion of the crew access arm directly to the spacecraft structure. A remotely operated clamp located on the roof of the crew access arm white room engaged the vehicle at the base of the launch escape system. Relative motion was absorbed within the crew access arm rather than at the interface. The remotely operated clamp also permitted firing room personnel to connect to the vehicle during an emergency while the crew focused on hatch operations. A key factor that needs to be resolved early in the design process is how the crew access arm will attach to the spacecraft itself. In general, the goal of attaching the vehicle to the crew access arm is to eliminate the relative motion between the two assemblies and allow a better chance of achieving the desired environmental seal at the interface. However, this must be done without damaging or adding mass to the vehicle.
Crew ingress. Access into vehicles should be designed to minimize any damage or contamination to hatch seals or mechanisms. In this case, a diving board is used.
Crew access for manned spacecraft is a secondary concern for designers compared to on-orbit vehicle performance. However, the components impacted by crew egress are substantial and include the crew hatch, the outer surfaces, the launch abort system, and all crew equipment that could impede escape.
Assisted emergency egress. The vehicle and pad designs need to support rapid removal of crew that are incapacitated during emergency egress. Hatch size must not only accommodate crew and cargo, but rescue and breathing equipment used by emergency personnel.
The ability of a crew to rapidly exit their spacecraft and escape a pad emergency is perhaps the strongest driver in the crew access arm design. Crew should be oriented with their heads toward the hatch if possible to allow for quick extraction.
In some cases, special equipment is required to assist the rescue team if the vehicle geometry impairs extraction of injured crew.
Events such as the Apollo 1 pad fire elevate the importance of a coordinated solution that allows the crew to get out of the vehicle rapidly without penalizing on-orbit capability.
Several design details can significantly improve emergency extraction times, such as rapid release flight crew equipment, suits with handles built in, and cabin layouts that provide emergency personnel with working volume around the crew seats.
Flight suits and breathing apparatus worn by the emergency rescue personnel should be considered when planning minimum space requirements of interior compartments. To ensure no obstacles impede the crew, careful attention must also be paid to the egress route. In order to remove incapacitated or injured crew from the crew compartment and away from the vehicle, support equipment must be designed to minimize interference with the spacecraft.
Unassisted emergency egress. In situations where the crew must egress without assistance, handrails and footholds are critical for quickly crossing the gap between the vehicle and white room.
Tools should not be required to enable crew egress.
The limited mobility within a crew suit increases the need for mobility aids within the vehicle and at the edge of the white room. This egress method and landing are the two primary driving cases for placement of handles around the hatch area.
Vehicle purge design should minimize overpressure required at the crew access arm vehicle interface. Purged areas of the spacecraft must include a recovery plan for loss of purge. In other words, what happens if the purge is lost or the mission is scrubbed.
The KSC mock-up team has presented a series of design considerations for crew compartment access. This area is ripe for new and innovative approaches, particularly if the workers that will be using the hardware and the emergency personnel that protect the crew are involved early in the design process. Contact NASA Kennedy Space Center or the personnel below for further information.